What we want to do is have some examples, take you through some problems, get us a feeling of how these are going to work, and then I'll give you a couple of problems afterwards to do tonight for homework. All right, so let's take a look at our example here. Our example is a blade of a windshield wiper moves through an angle of 90 degrees in about 0.28 seconds. So time, 0.28 seconds. And it's a 90-degree angle. All right. And the tip of the blade moves to the arc of the circle. So this is the arc of the circle that we're looking at. Okay, and the arc of that is 0.76 meters is the arc. Okay, and what we want to know is what's the magnitude of the centripetal acceleration at the tip of the blade. So we want to know right here, how fast is that blade going? All right, so we start out with our equation. Okay, velocity centripetal is 2 pi r divided by the period, or the time. So let's see if we can plug in our values and see what we get here. So 2 pi, all right, and r is 0.76, okay, and that's going to be VC equals, okay. And now this was time, which is our period, is 0.28 seconds, but wait a minute, we only went 90 degrees. So let's see, a circle is 90. Well, that would only be a quarter, so therefore we're going to have to multiply that by 4, because in order to get the full circle that we did. So this whole circle is what we need, okay, for our time. Because if it moves through that section at that pace, then it has to do the next section at the same, next section. So we multiply it out by 4. All right, so now let's see what happens. So we get velocity centripetal, 2 times pi times 0.76. We're going to get, when we do that out, 4.26 meters per second. Okay, that's going to get us our velocity centripetal, but we didn't want velocity, we wanted acceleration. So acceleration centripetal is going to be v squared over r. Okay, so now we know what v squared is. So now acceleration centripetal is going to be 4.26 squared divided by the radius, which we had was 0.76. So now to get acceleration, oh wait a minute, this is meters per second, so this is going to be meters squared seconds squared, and this is going to be meters, oh wait a minute, acceleration is meters per second squared, so a meters, okay, so we've got our units are all set. So now we're going to divide this out, and we find out acceleration centripetal is 23.96 meters per second squared. So there is our first example. The first thing we did was we found the velocity of the wiper. Then we took that velocity and we figured out what it was for acceleration. We took the acceleration equation right here, and we got our answer. So our answer for this particular question is 23.96 meters per second squared. Okay, new problem. Problem number 2. This is a record player. I know you don't know what a record player is, because there's a thing where you put records on it, and it was a turntable, and it spun around, and it went at a certain speed, and so on. Used to listen to records. Back in my day, we used to listen to records, and that's how we did it, you know, before we had CDs. Okay? So what we want to find out is this was going to spin around. All right, so as it's going around, what's going to keep that coin, or that object from not sliding off. Because as we know from Newton's first law, an object in motion wants to stay in motion in a straight line forever unless acted on by a force. So there's going to have to be some friction there. So let's start with our free body diagram. So our free body, we're going to have, here's my coin, okay, and there's going to be a force going in that direction, okay, which is going to be the force of friction. Well, we've had that before. All right, we have forces going this way, which will be mass times gravity, mg, and the object is not going anywhere up and down, so that means that it has to be a force going in the other direction, which would be force normal. So we have force normal, we have force going down, mass times gravity, and we have the force of friction, which is keeping it on play. All right, so let's see what's going on. Now we've got a picture of it. Now we've got to try to solve this problem. Well, let's see. If the turntable is spinning in this direction, okay, and it's going at 33 1/3 revolutions per minute, RPMs, okay, and let's have the diameter of this be, let's make it 0.30 meters, okay, so let's see, radius is, that's right, half of the diameter, so that would be 0.15 meters. All right, so now we're looking at this here. So we have how many revolutions per minute. So that's how fast it's going around here. And we know the radius. So now we just have to figure out what the friction, mu, of the coin is so that it doesn't go off the turntable. So it doesn't go off the turntable. So we got how many friction, how fast can it be going so that that coin does not go flying off.